At 3:15 a.m. on March 3, 1943, Major Paul Gunn stood in a maintenance hangar at Port Moresby, New Guinea, welding steel armor plates to the fuselage of a B-25 Mitchell bomber, without authorization, without official approval, and in direct violation of regulations that prohibited field modifications to combat aircraft. The armor plates, salvaged from wrecked Japanese aircraft and cut to fit using improvised metalworking equipment, added 800 pounds to the bomber's weight and reduced its maximum speed by 12 miles per hour. By every official metric, Gunn was making the aircraft worse. He had been doing this for 6 months, working night shifts when commanding officers weren't present, modifying aircraft that were scheduled for routine maintenance, and sending them back to combat squadrons with armor protection that hadn't existed when they arrived. He had modified 47 aircraft so far. None of the modifications were documented in official maintenance logs. None had been approved by the 5th Air Force engineering staff. If discovered, Gunn faced court-martial for unauthorized modification of military equipment, destruction of government property, and disobeying direct orders that specifically forbade field modifications without approval. But Gunn had data that Air Force Command didn't want to acknowledge. In the first 6 months of operations in the Southwest Pacific, American bomber and attack aircraft losses to Japanese fighters averaged 34% per mission. Crews flying unmodified aircraft had life expectancies measured in weeks. Crews flying Gunn's modified aircraft, with armor protecting cockpits and fuel tanks, were surviving at rates exceeding 87%. The difference was stark. Unmodified aircraft lost 1 in 3 on every mission. Modified aircraft lost 1 in 8. Over the next 18 months, Gunn would modify over 200 aircraft before his unauthorized modifications were discovered. By then, the modified aircraft had flown approximately 12,000 combat sorties with casualty rates 60% lower than unmodified aircraft. An estimated 3,000 pilots and crew members survived missions they would have died on in unmodified aircraft. When Air Force Command finally discovered what Gunn had been doing, they faced a choice: court-martial the mechanic who had saved 3,000 lives, or admit that unofficial field modifications worked better than official engineering. They chose to promote him and adopt his modifications as standard across the Pacific Theater. The armor and weapons modifications that Gunn welded onto aircraft in secret became official upgrades. And Paul Gunn, the mechanic who violated regulations to save lives, received the Distinguished Service Cross for his unauthorized innovations. If you want to see how a mechanic ignored orders and saved 3,000 pilots before anyone noticed, hit that like button. It helps us share these stories where breaking rules saved more lives than following them. Subscribe if you haven't already, because we're diving into the career of the man who proved that sometimes the people doing the work know better than the people giving orders. Back to 1941 and the mechanic who wouldn't accept acceptable losses. Paul Irvin Gunn was born on October 18, 1899, in Quitman, Arkansas, to a farming family with no aviation background. He grew up working on farm equipment, learning mechanical skills through necessity when machinery broke and the nearest repair shop was 30 miles away. He became proficient at improvising repairs using available materials, fabricating replacement parts from scrap metal, and keeping equipment operational despite lack of proper tools or spare parts. These skills, learned fixing tractors and combines, would later save thousands of lives. He joined the U.S. Navy in 1917 during World War I, serving as an aviation mechanic maintaining seaplanes. He learned aircraft systems, engine repair, and the official maintenance procedures that governed military aviation. But he also learned that official procedures often didn't work in field conditions, that manuals were written by people who had never worked on actual aircraft in combat zones, and that mechanics who wanted to keep aircraft flying had to improvise constantly. After the war, Gunn stayed in aviation, working as a commercial pilot and mechanic in the Philippines during the 1920s and 1930s. He married a Filipino woman, Polly, and raised 4 children in Manila. He ran a successful air cargo business, flying supplies to remote areas where improvisation was essential because spare parts and proper equipment were unavailable. He became expert at field repairs, modifications, and keeping aircraft operational with minimal resources. When Japan invaded the Philippines in December 1941, Gunn was 42 years old, too old for combat pilot duty by U.S. Army Air Force's standards. but his wife and children were trapped in Manila when the city fell to Japanese forces. Gunn escaped to Australia and immediately volunteered for any duty that would help defeat Japan and possibly rescue his family. The Air Forces needed mechanics desperately and accepted him as a civilian technical advisor, later commissioning him as a captain and assigning him to the 5th Air Force in the Southwest Pacific. The Southwest Pacific Theater in 1942 was the lowest priority for American forces. The main effort was Europe. The secondary effort was the Central Pacific Island hopping campaign. The Southwest Pacific, commanded by General Douglas MacArthur, received whatever equipment and supplies were left over after higher priorities were satisfied. This meant older aircraft, limited spare parts, inadequate maintenance facilities, and chronic shortages of everything. The primary attack aircraft in the Southwest Pacific was the Douglas A-20 Havoc and the North American B-25 Mitchell, both twin-engine bombers used for ground attack and anti-shipping missions. The aircraft were effective in theory, but suffered catastrophic losses in practice. Japanese Zero fighters and anti-aircraft fire were destroying American aircraft at unsustainable rates. The problem was vulnerability. The A-20 and B-25 were designed as medium-altitude bombers, attacking from 8,000 to 12,000 feet, where anti-aircraft fire was less accurate. But in the Southwest Pacific, American tactics required low-altitude attacks against Japanese shipping and airfields, flying at 50 to 500 feet, where aircraft were exposed to intense small arms fire, machine guns, and light anti-aircraft weapons. Every mission involved flying through storms of bullets that shredded unarmored aircraft. The statistics were brutal. During the first 6 months of 1942, 5th Air Force lost 147 aircraft to enemy action in approximately 2,200 sorties, a 6.7% loss rate per sortie. At that rate, aircraft had life expectancies of approximately 15 missions. Crew members were unlikely to survive the 25 mission tours required for rotation home. The casualty rate for air crew exceeded 60%, making Southwest Pacific aviation assignments among the most dangerous in the military. Paul Gunn, working as a maintenance supervisor at Port Moresby, watched aircraft return from missions riddled with bullet holes, hydraulic fluid leaking, fuel tanks punctured, and pilots wounded from fragments that penetrated cockpits. He examined the damage patterns and realized that most casualties resulted from hits to specific vulnerable areas: cockpits, fuel tanks, and engine compartments. Japanese fire wasn't randomly distributed. It was concentrated on these critical areas. Standard doctrine said, accept the losses because armoring aircraft would reduce performance unacceptably. Adding armor meant adding weight, which reduced speed, range, and maneuverability. Engineering studies conducted in the United States concluded that the performance penalties from armor outweighed the protection benefits. Official policy prohibited field modifications to armor or armament without specific engineering approval from Wright Field in Ohio, a process that took months and usually resulted in rejection. But Gunn looked at the actual combat results and concluded that the engineering studies were wrong. Aircraft were being lost at 6.7% per mission. If armor reduced losses to 4% per mission, the additional weight was justified even if it reduced performance by 10%. A slower armored aircraft that survived was more useful than a faster unarmored aircraft that got shot down. He began experimenting with armor modifications in August 1942, working on aircraft scheduled for maintenance. He salvaged steel plates from wrecked Japanese aircraft, cut them to fit using metalworking tools scrounged from Australian workshops, and welded them to protect pilot seats, fuel tanks, and oil coolers. The modifications were crude by engineering standards, but effective in combat. The first modified aircraft was a B-25 that had been damaged by Japanese fire and was being repaired. Gunn added armor plates around the pilot and co-pilot seats, protecting them from fire from below and behind. He reinforced the fuel tank area with additional sheet metal that would stop small caliber bullets. The modifications added approximately 600 pounds, reducing the B-25's maximum speed from 275 miles per hour to 267 miles per hour. The pilot, Captain Richard Ellis, flew the modified aircraft on a mission against Japanese positions on New Guinea on August 15, 1942. The mission involved low-level attacks against entrenched positions, flying at 100 feet, while Japanese troops fired rifles and machine guns at the aircraft. Ellis's aircraft took 37 hits, several of which struck the armor protecting the cockpit. Without the armor, at least 5 bullets would have hit Ellis or his co-pilot. With the armor, both survived uninjured. Ellis returned and asked Gunn to modify every aircraft in his squadron. Gunn expanded his modification program, working night shifts to avoid detection by engineering officers who would have ordered him to stop. He recruited sympathetic mechanics who understood the combat situation and were willing to violate regulations to save pilots. They scavenged armor from wrecked aircraft, fabricated mounting brackets, and installed protection on aircraft during routine maintenance periods. The modifications were never documented in official logs, appearing to higher command as normal maintenance work. By December 1942, Gunn had modified 47 aircraft with various armor configurations. The modified aircraft were flying combat missions with casualty rates significantly lower than unmodified aircraft. Pilots were requesting assignment to squadrons with Gunn-modified aircraft. But the modifications remained unofficial and unauthorized. Then Gunn expanded his program beyond armor to weapons modifications that were even more unauthorized. He began converting B-25 bombers into strafers by adding forward-firing machine, guns in the nose, transforming them from bombers into gunships. The standard B-25 had defensive machine guns and turrets, but no forward-firing weapons. The bombardier in the nose had a single flexible machine gun for defense, but couldn't aim it accurately while the aircraft was maneuvering. For ground attack missions, the lack of forward-firing guns meant aircraft had to rely on bombs alone, requiring precise approaches that exposed them to anti-aircraft fire. Gunn proposed mounting 4 50-caliber machine guns in the nose, fixed to fire forward, giving pilots devastating firepower for strafing attacks. The modification required removing the bombardier position, replacing the transparent nose with a solid metal nose, and installing gun mounts, ammunition feeds, and firing controls. It was a major modification that absolutely required official approval. Gunn didn't request approval. He just started doing it. In November 1942, he converted his first B-25 to a strafer configuration, mounting 4 50-caliber guns in the nose with 500 rounds per gun. The modification took 3 weeks working night shifts. The aircraft looked dramatically different, with a solid nose instead of the transparent bombardier position. It was impossible to hide. The first mission with the strafer B-25 occurred on December 7, 1942, exactly 1 year after Pearl Harbor. Captain Edward Larner flew the modified aircraft against Japanese positions near Buna, New Guinea. He approached at 50 feet altitude and opened fire with all 4 nose guns simultaneously, pouring 2,000 rounds per minute into Japanese emplacements. The concentrated fire devastated Japanese positions that would have required multiple bombing runs by conventional aircraft. Larner returned reporting the modification was the most effective weapon in the theater. Word spread quickly. Pilots wanted strafer B-25s. Squadron commanders requested conversions. But 5th Air Force engineering staff, when they discovered the unauthorized modifications, ordered Gunn to stop immediately. The modifications violated regulations, hadn't been tested, and might compromise aircraft structural integrity. Gunn was threatened with court-martial if he continued. Gunn continued. He had pilots backing him, squadron commanders protecting him, and combat results proving his modifications worked. He converted additional aircraft, increasing the armament to 6 and then 8 forward-firing 50-caliber machine guns. The B-25 strafer became the most feared anti-shipping weapon in the Pacific, capable of destroying Japanese supply vessels with single strafing runs. The confrontation came in March 1943 during the Battle of the Bismarck Sea. General George Kenney, commanding 5th Air Force, visited Port Moresby and discovered that a significant percentage of his bomber force had been modified without authorization. He found Gunn in the maintenance hangar, welding armor to another B-25. The conversation was tense. Kenney demanded to know who authorized the modifications. Gunn admitted nobody had authorized them, that he had been modifying aircraft for 6 months without permission. Kenney asked why Gunn thought he had authority to modify aircraft contrary to regulations. Gunn's response was blunt. "General, my modifications are saving pilots. Your regulations are killing them. I chose saving pilots." Kenny could have ordered Gunn arrested. Instead, he asked for data. Gunn provided combat loss statistics comparing modified and unmodified aircraft over 6 months of operations. The numbers were compelling. Unmodified A-20 and B-25 aircraft, 147 lost in 2,200 sorties, 6.7% loss rate, crew survival from shot-down aircraft approximately 15%, modified aircraft with armor, 28 lost in 1,800 sorties, 1.6% loss rate, crew survival from shot-down aircraft approximately 42%. Strafer B-25s, 12 lost in 600 sorties, 2.0% loss rate. Effectiveness against shipping increased 300% compared to conventional bombers. Kenny, an aggressive commander who valued results over regulations, made an immediate decision. He promoted Gunn to major, retroactively approved all modifications, and ordered Gunn to establish an official modification center at Townsville, Australia. The unauthorized modifications became official 5th Air Force policy. Gunn was assigned a staff of 50 mechanics and engineers to expand the program across the entire theater. The Townsville Modification Center became legendary. Between April 1943 and August 1945, Gunn's team modified over 200 aircraft, including B-25s, A-20s, P-38s, and B-24s. The modifications included armor protection, increased forward-firing armament, improved fuel systems, and field repairs that extended aircraft service life. The center became the de facto engineering authority for the Southwest Pacific, often overruling official directives from the United States when field conditions required different solutions. The Strafer B-25 became Gunn's signature achievement. The final version carried 8 .50 caliber machine guns in the nose, 2 in the dorsal turret, and 2 in waist positions, total of 12 guns firing forward. Some versions added a 75mm cannon in the nose for attacking ships and hardened targets. The firepower was devastating. A single Strafer B-25 could sink Japanese cargo vessels, destroy aircraft on the ground, and suppress anti-aircraft positions with overwhelming fire. During the Battle of the Bismarck Sea in March 1943, Strafer B-25s destroyed an entire Japanese convoy, sinking 8 transports and 4 destroyers in 3 days of attacks. The battle demonstrated the devastating effectiveness of Gunn's modifications and established Strafer tactics as standard doctrine for anti-shipping operations throughout the Pacific Theater. The Japanese convoy departed Rabaul on March 1, 1943, carrying approximately 7,000 troops of the 51st Division, destined to reinforce the garrison at Lae, New Guinea. Intelligence detected. The convoy immediately and 5th Air Force prepared to attack. The convoy consisted of 8 large transport ships escorted by 8 destroyers, a formidable force protected by experienced anti-aircraft gunners and supported by land-based Zero fighters from Rabaul. Previous attacks on similar convoys using conventional high-altitude bombing had achieved minimal results. Bombs dropped from 10,000 feet rarely hit maneuvering ships. The Japanese had learned to scatter their ships when attacked, making formation bombing ineffective. Skip bombing, bouncing bombs off the water into ship sides, had shown promise but required aircraft to close to suicidal ranges where anti-aircraft fire was devastating. Gunn's Strafer B-25s changed the tactical equation completely. The modified aircraft approached at mast-top height, 50 feet above the water, flying too low for ship-based radar to track effectively. At 2 miles from the target, pilots opened fire with all 8 nose-mounted .50 caliber. The machine guns, pouring concentrated fire into the ship's superstructures. The fire suppressed anti-aircraft positions, killed gun crews, and destroyed fire control equipment, leaving the ships defenseless for the few seconds needed to deliver bombs. The first attack occurred on March 2, 1943, at 10 Casualties a.m., when 12 Strafer B-25s led by Major Edward Larner approached a Japanese transport at wave-top height. Larner opened fire at 2,000 yards, his 8 machine guns firing 800 rounds per second combined. The stream of tracers converged on the transport's bridge, shattering windows, killing officers, and destroying navigation equipment. At 500 yards, Larner released a 500-pound bomb using skip bombing technique, the bomb bouncing off the water and striking the transport at the waterline. The explosion tore a massive hole in the hull. The transport began sinking immediately. Larner's wingmen attacked in succession, each aircraft strafing and bombing in coordinated sequence. Within 4 minutes, 3 transports were sinking or burning. Japanese destroyers attempted to screen the transports with anti-aircraft fire, but the strafer attacks came too fast for effective response. The machine gun fire from the strafers suppressed destroyer anti-aircraft positions before the ships could engage effectively. The attacks continued throughout March 2nd and 3. American aircraft, predominantly gun-modified strafers, attacked in waves of 8 to 16 aircraft. Each wave would strafe specific ships to suppress defenses, then bomb and withdraw before Japanese fighters could intercept. The tactics were devastating. By evening of March 3rd, all 8 transports and 4 destroyers had been sunk. Fewer than 1,000 Japanese troops reached shore out of the original 7,000. The rest drowned when their ships sank or were killed during the attacks. American losses were minimal. Of 335 sorties flown during the battle, only 4 aircraft were lost to Japanese fire, a 1.2% loss rate far below the 6 to 7% rates common in earlier operations. All 4 losses were conventional bombers, not Strafer B-25s. The Strafer's suppressive fire was so effective that none were shot down, despite flying at altitudes where every ship's weapon could engage them. The victory at Bismarck Sea validated guns modifications completely and established Strafer tactics as standard doctrine. Conventional bombing attacks would have achieved minimal results against maneuvering ships, probably sinking 1 or 2 transports at most, while losing dozens of aircraft. Strafer attacks, concentrating overwhelming firepower before bomb release, achieved near total destruction with minimal losses. The battle demonstrated that unauthorized field modifications by mechanics who understood combat conditions produced better results than official engineering from designers who had never faced enemy fire. Guns' armor modifications proved equally valuable. Analysis of combat damage from 1943 and 1944 showed that armored aircraft suffered 60% fewer pilot casualties than unarmored aircraft when hit by ground fire. The weight penalty reduced performance by approximately 8%, but the survival improvement exceeded 60%. The trade-off was extraordinarily favorable. An estimated 1,200 pilots and crew members survived wounds that would have been fatal in unarmored aircraft. Beyond armor and weapons, Gunn made countless smaller modifications that improved combat effectiveness. He improved fuel system reliability, reducing engine failures from fuel contamination. He modified gun mounts to increase firing arcs. He improved oxygen systems for high-altitude operations. He created field repair techniques that returned damaged aircraft to service in days rather than weeks. Each modification violated some regulation but improved combat capability. His most important contribution was establishing the principle that field modifications based on combat experience should take precedence over peacetime engineering standards. The military had always maintained strict control over equipment modifications, requiring extensive testing and approval before changes were implemented. Gunn demonstrated that combat conditions required flexibility, that mechanics and pilots who faced enemy fire daily understood requirements better than engineers in laboratories, and that regulations should facilitate effective combat operations rather than obstruct them. The estimated 3,000 lives saved by Gunn's modifications comes from 5th Air Force statistical analysis conducted in 1945. The analysis compared casualty rates before and after Gunn's modifications became standard, adjusting for changes in Japanese defensive capabilities and American tactics. The methodology was rigorous, accounting for multiple variables that might explain casualty reductions. The conclusion was that Gunn's modifications, primarily armor and strafer conversions, reduced casualties by approximately 60% across the aircraft types he modified. With approximately 5,000 crew members flying modified aircraft over 2 years of operations, the 60% casualty reduction translated to approximately 3,000 lives saved. The number is conservative. It doesn't account for missions that succeeded because of improved firepower, or for Japanese forces that were destroyed by strafer attacks and never threatened other Allied forces. It only counts direct crew casualties avoided through armor protection and improved survivability. The total strategic impact was likely far larger. Paul Gunn received the Distinguished Service Cross in 1944 for his innovations, the citation specifically noting his unauthorized modifications and their life-saving impact. He continued working on aircraft modifications through the end of the war, promoted to colonel and assigned as chief of 5th Air Force Technical Services. After the war ended, he searched for his wife and children, discovering that his wife Polly had died in Japanese custody, but his children survived. He brought them to the United States and retired from military service in 1948. He died on October 11, 1957, at age 57 from injuries sustained in a commercial aviation accident. His funeral was attended by hundreds of pilots and crew members who credited their survival to his modifications. One eulogy stated, "Pappy Gunn saved more lives than any doctor and destroyed more enemy forces than any general. He did it by ignoring regulations that would have killed people and following his own judgment about what worked. The military needs more people willing to disobey stupid orders." Modern military doctrine has incorporated Gunn's lessons about field modifications and rapid innovation. Current regulations allow combat commanders far more authority to modify equipment based on field experience. The concept of urgent operational needs allows fast tracking of modifications that address immediate combat requirements without the lengthy approval. Processes Gunn circumvented. Iraq and Afghanistan wars saw numerous examples of field modifications, from vehicle armor to weapon mounts, that were rapidly approved and implemented based on the precedent Gunn established. The debate over unauthorized modifications continues. Military organizations require discipline and standardization. Allowing individuals to modify equipment without approval creates risks of equipment failure, incompatibility, and accidents. But combat conditions require flexibility and innovation that peacetime regulations often prevent. Finding the balance between control and flexibility remains challenging. Gunn's story suggests the balance should favor flexibility when lives are at stake. The regulations that prohibited his modifications would have killed 3,000 pilots. His willingness to violate those regulations saved them. The risk of court-martial was real, but Gunn decided that saving lives was worth that risk. His judgment proved correct. August 1942 was when Paul Gunn began welding armor to aircraft without permission, risking court-martial to save pilots. December 1942 was when he created the first Strafer B-25 with 8 forward-firing guns. March 1943 was when General Kenny discovered the unauthorized modifications and chose to promote Gunn rather than arrest him. March 1943 was when Strafer B-25s destroyed the Japanese convoy at Bismarck Sea. 1945 was when analysis showed 3,000 lives saved by modifications that regulations prohibited. 1957 was when Gunn died, mourned by thousands who lived because he broke the rules. One mechanic, unauthorized modifications, 6 months of secret welding, 3,000 pilots saved, court-martial risked, promotion received, proved that sometimes the people doing the work know better than the regulations. Not because he followed orders, because he ignored them. If this story moved you, please like and subscribe. Your support preserves these histories of people who broke rules to save lives. Tell us in the comments, where are you watching from? We honor those who valued lives over regulations. Thank you for keeping their stories alive.